you're viewing a video, it's not always that you're just going to be passively watching. There's data being involved here. You know, we're getting some data streaming back to our server. So the video event, now I've said this publicly before, I'm going to say it again. I totally ripped this off from Netflix. They do this, and they use Cassandra to do it. When you're watching a video, I want to keep an eye, I want to keep a stream and figure out where you're at on the video. Because I think it's a great feature that if you stop your video and you come back, you want to start right where you left off, right? Not from the beginning again. So I don't think this is a very foreign feature, but it is cool, and I better have it, or else everyone's not going to be on my website. So how am I going to do that? So what I'm going to do is I'm going to track all the events for a particular video and a user. So the concept here is that I have a person watching a video. So those two things are linked together. That's a unique event. And so that's what I'm going to create. So I'm going to have a video username, and which is going to be my key. And that's just going to be, I'm going to construct those. We're going to cap those together. And that's going to be a unique key, just the string operation. Then I'm going to have an event, which is a start or a stop. Those are the two events that I'm going to be tracking. And a timestamp of when that happened, and then a value of the video timestamp. So I want to be able to put the video player back to where they were watching the video, not just what time it was that they did it. So this is what I'm going to be able to do. When I hit start on the video, it'll mark the timestamp. Okay, here's when you started, and I get 5 minutes into it, and I'm like, oh, it's time for dinner. Click stop. And that event will get logged in this table, in this column. I come back, watch a couple minutes more, my kids start a fire, stop, go out and deal with that, then I come back, I can start again. All those events are going to get tracked in here. So let's say you have an hour-long video and my kids are really bad tonight, I might start and stop like 10 or 15 times. I want to be able to do that as much as I want. I also want to be able to, if I rewatch the video again, I want to be able to track that through some analytics. And this is actually a very clever way of analyzing data and usage of your system. Because then you can track, again, 2 billion events. And if you're watching that video 2 billion times, you need a good life. You can have a lot of events being tracked, and you can use that. Hey, you watched that video from start to finish 3 times. Or, would it be more interesting to see how many people out there watched during the first 5 minutes of this half-hour video? So there's some fascinating big data topics in there. So what I'm going to do, so when I create this table, now we're getting into the advanced users, because you're now all advanced users. So keep learning this. We're going to add this little clause at the end of our create table. And what this is doing is, and I should preface this is all based on the latest version of the CQ. So this is what's going to be coming out in version 1.2 here very shortly, Cassandra 1.2. If you're using an older version and you have trouble, you saw my Twitter, hit me up. Their CQLs is going to be finalized in 1.2, so some of the syntax is newer. But I wanted to give you the newest, the greatest, because that hopefully you're going to be using the newest and greatest. So this syntax right here, this clustering order by, what this does is, it looks very strangely relational, but it's not. What you're doing is you're actually saying how the data is laid out on a disk. You're setting a sort order. And this is really important because it's an efficiency operation. What I'm saying is I want the event timestamp to be reversed, the decrement. So what this is going to do is now the last event, the latest event that happened is going to be the first one, the first column. So it's going to be the latest event to the oldest event. So the first time I started the video is going to be way over here by the speaker. And then the first one, that first row, or the first column, will be the last thing that happened. So the efficiency is now, whenever I want to say, okay, what's the last thing that happened? I just grab the first column. That is guaranteed to be the last thing that happened. Very efficient operation. You don't have to, let's say that was a very popular video for this one user, and they started and stopped it hundreds of times. Well, you don't have to get all that column data and get to the very end to find out what the last thing that they did. It's better to flip it around. So that's what the reverse comparator can do. Very popular. And I think there's a lot of people who use this very effectively for just this reason. Time series data in Cassandra seem to fit really well, especially with reverse comparator, because it fits kind of in our brain. you do want to know the last thing that happened. That was a big one. Okay, so now we went through all the entity tables. We did our one-to-many, our many-to-many, our plain old Java object tables. So what about query tables? I mentioned secondary indexes are fine, but there's cooler ways of doing it. And because you're in CodeChix, you don't in a cool way. So index tables. So what I'm going to show you is how to build your own indexes. Now I know that pretty little MySQL database you have does it for you for free. It's not free. It's very expensive because whenever you create a lot of indexes on a relational table, what's the first thing that happens? It starts slowing down. You start rebuilding indexes. So this concept of having an index is just going to work because I'm going to show you how to do it. So the index table principles. There's two things we're going to learn from this. First thing is you want to index by row key. The row key is really going to be what you want to look for first. The reason being is that it's very fast because it's cached and it's indexed inside Cassandra, and it's just one unit. I say cache most times. You can turn off the cache if you want. I don't recommend it. But you're going to look up row key number 5. Bam, it's very fast. So now you do a row key lookup. So what's the second thing you're going to do? You're going to get the data out of the row. So an index starts with what is being indexed and then the data that follows that index. And I'm going to show you an example here in the next slide. So we have this index table, which has, I'm going to grab column key 5, and what I really need is column 3 through 6. And this is supposed to illustrate what I was telling you earlier. The operation on the disk is sequential because it's a string sorted table. This is what makes it really fast. You do a row key lookup, do a slice, very fast operation, milliseconds, less than seconds. So this type of operation is how you want your indexes to be formed, and we're going to do that. Again, this can be cached as well, too. Not as common to see the actual row data cached as much, but it can be done. Given enough memory, you can probably cache your entire database. So we're going to do that with our video by username. So I said, yeah, we could create a secondary index on video or username on the video table, but this is the cooler way to do it. So what I did is I created a column family that is going to sort all the videos for one user. And how I'm doing that, so I created a column family. The primary key is the username, so one lookup. If I have a user logging in, so let's take this from the concept of the application. I have a user that logs into the website. We know who they are because they typed in their username, so you have the key. Now, whenever they go to the web page, I want to show all their videos on there. So I want to do one pass. So I'm going to take the username, and I also have video IDs, the upload date, and the video name, all arranged in a column family. So this is a wide row. So as the users are adding new videos, we put the video ID and the timestamp that they did it. It's a sorted table, so the timestamps keep all of that in order, and we could reverse that if we wanted to. But so now, whenever I ask, give me all the videos for this particular user, two things happen. Row key, bam, we're at the row. Slice, grab all the videos. Two operations, very quick. This is what's called a query table. Cassandra, this is a very important concept to know. This is what's going to speed up your lookups. So what I get out of this is now I have two places. I said there's going to be, it's okay for data to live in two places. Now I have two places where my data lives. Things that I could do with this table too is if I wanted to look at a certain time frame, I can change my slice parameters. I could say, give me this video, and I only want to know the videos are updated, they were uploaded 6 months ago. Bam. You can set your timestamp, do a slice on that. Very quick operation. So whenever I add a new video, I have two things. I have to write to the video table, and I have to write to this table. Two things at once. Using most of the client libraries, that's called a batch mutate. You can do two operations at once. Very efficient operation. Very common in Cassandra. That's one of the concepts to really get your head around is it's okay to write to multiple tables at the same time. Again, Cassandra loves writes. I mean, it's built to do writes. If you need to do thousands of writes per second, Cassandra's going to do it. So don't be afraid to do writes. If you have to do 3 or 4 operations or even 100 for every operation, like when a new user is created or a video is uploaded and it has to update 100 column families, that's okay. It'll take it. So the other thing you have to manage is if a video is deleted in the system. That's a little more logic on the database, but in your application against the database, but it's okay because you got all the speed now. You're going to scale. So here's another one, similar concept, the tagging. So in our video table or our video, we also had a tag, like a setup where we created like a delimited format tag or some sort of structure tag, JSON or something. Well, you don't want to have to search for that because that means you're going to have to go look. That's like a full table scan. You're going to have to go into the video, each video, get that column name, look inside the data. You don't want to do that. So this is where a good query table comes in as well. So I'm going to just create a tag table. So the string tag, whatever it is, like cat video, cat, LOL, whatever the tags may be, I'm going to create an index for each one of those. So this is where that multiple write comes in. So the tag is a unique part of this video. Well, what if I added 5 tags to a video that I'm uploading? Well, you're going to have to write to 5 columns or 5 different rows at the same time, which is fine. So what we're going to get out of this is a quick way to look for, I want to find all the videos for this particular tag, the cat videos. And you can put everything in timestamp order, so in case you wanted to sort by timestamp, that's doing it too. But because, again, this is an index table, you're going to have to maintain the integrity inside that. That's the only caveat. But this is going to be very fast. Again, row key lookup, slice, bam, bam, there's your data. All right. So let's talk about deploying this thing. So now we've got our application. Killer video is ready. Spent all night writing Ruby code. Or no, it's only a couple hours, right? Ruby's really fast. I did it in Java. I'm kidding. Took me all day. So we wrote our app. We're ready to deploy this thing. So this is where we get into deployment of Cassandra, but it's also considerations about when you write your application. So I got a little pretty picture here. This is the Cassandra ring picture, and I think I ripped this off from somebody, so it's not completely applicable. But I wanted to show the concept of how a cluster is deployed. So we're going to have a ring. We may have it in 2 data centers. So there's a lot of things we're going to have to consider here. So consideration number 1, it's just me in my garage. I don't have a lot of money. I'm probably going to put this up on Amazon. And if it goes down because Amazon went down, I'm just going to put up an I'm sorry page. Okay, so there's my factor. So my replication factor, I'm going to create a small cluster, maybe 2 or 3 machines, and I'm going to keep the replication factor pretty small. Multi-data center? Probably not. And the reason being, cost. I don't want to have to spend a lot of money because my kids need shoes or something. But let me flip that around. Now, I'm a Fortune 500 company. We're rolling out a product, and killer video is really important. And if my boss says I'm going to get fired if this thing goes down. Wow, that changes things quite a bit, doesn't it? So now I'm going to have my 20-node cluster up in 2 data centers with a high replication factor, and cost still pretty low. So we're going to have all these considerations, but your application really needs you need to think about this in your application. Are you going to need a lot of writes? That's one of the things. Is it going to ingest a lot of data? That's one of the things you need to think of too. But you don't have to worry about the scaling factors of performance just as much, and I'll show you why in a second. But these are all considerations for your deployment. So if you're deploying into Amazon, if you're going into your own private data center, let me just give you these little tidbits about deployment. Do not buy the biggest possible machine you can possibly buy, because that's not what Cassandra lets. And we talk about deploy this on commodity servers. We really mean commodity servers, not the biggest box that Dell will sell you. What we say is that Cassandra runs good of many of less. So small one-use servers, tons of them, maybe rack servers in a private data center. In Amazon, it runs great M1 extra larges or bigger are awesome. It really runs well in a large cluster. In small machines, so many of less. So, you know, I know that people want to put databases on the biggest machine possible because that's what we all learned from Oracle and MySQL. And that works there because it doesn't replicate and it doesn't cluster very well. So how does that fit with, say, our performance problem? So when we're doing our performance analysis and we're saying, okay, how's this going to scale? So this is what I used to have to do. I would get the requirements from our business people, and I talk to developers. I'm like, okay, this is going to be a really hard-hitting app. So what we got to do, okay, we're going to buy the biggest box from Dell. We're going to get 24 disks in there. We're going to do RAID 10. We're going to just put all this stuff on there. Okay, that's because I'm sizing the box to a certain thing, like the peak load. Cassandra is not about that. What is good for today is not tomorrow's problem. Tomorrow will solve itself, and I'll show you why. So if you can have a reasonable assumption, hey, I'm going to have a few thousand users on our site. They're only going to put a few gigs of data on there a day. Small cluster. But what happens whenever it gets on Slashdot or Hacker News and it's really taking off? What are you going to do? That's where Cassandra really helps you out. Because what you're going to be able to do is scale when you need to. Adding another node is how you scale. If you need to make your database bigger, you just add more machines. And it's linear. It does not bring down your cluster. You can do it without bringing down your cluster. You can actually watch, there's a video we have on our website. Netflix did this on stage. They doubled the size of the cluster while everyone was watching. They doubled the size. And they went from something like a few 100,000 writes per second up to 1 million writes per second on stage, just clicking buttons and talking. So it's very doable. But if you're not Netflix and you don't have your plan together, you better have one, and that's really the key. When you need to expand and do the horizontal scaling that Cassandra will do, you need to have a plan. And that doesn't mean call Dell and order a couple new servers and then hope they show up within a week. So this is why I say you want to plan ahead. Because yes, it can scale quickly just by adding more nodes. Just be ready to do it. If you're in Amazon, a lot easier to plan. But again, I've seen plenty of people in Amazon that didn't have a good scaling plan together, and when you get hit really hard, sure, you could have upgraded, or you could have added more nodes quickly, but you didn't. So don't get caught in that position. It really changes the way, and DevOps is really the key here. You gotta embrace the DevOps on this. All right. So I'm going to talk a little bit about the extended parts of Cassandra that I'm going to add to my application. This is the enterprise, and of course I work for data stacks, so I'm going to explain why more than just Cassandra on top of this. So the enterprise part of Cassandra, the data stacks, is adding Hadoop and Solar. So I've already talked about, this is going to be the extended part of my application because it's really cool now, and I'm going to do this. So the enterprise adds Hadoop, and it adds Solar integration on top of Cassandra. And these are going to be really good for two reasons on our particular app. So the Hadoop is embedded with Cassandra. It doesn't add any single point of failure like, say, the Cloudera version does, where it has name nodes. And it uses the native Cassandra data. So what I'm going to do is I'm going to take that data table that had all my time series data, and I'm going to use Hadoop to do roll-ups. I want to find out, using Hive or Pig or Mahout, I'll use Mahout with Pig or Mahout with Hive, I'm going to find out how many people abandoned this, how many people abandoned videos along the way. And the best part is I don't have to transform any of my data. I'm just going to use Hadoop right on directly on top of my Cassandra data. So as data is being ingested by Cassandra, I'm running Hive jobs right on top of it, and I can roll, once that data is created through Hive, I can put it right back into a column family and use that directly to, say, drive recommendations. Wow, I have a video that everybody watches. I want to put that at the top of my recommended, or it has a really high rating and everybody watches. I want to put that at the top of my recommended. Or people with this particular user profile are watching this video more. I can use how to cluster those together. Now, Solar is going to add a different component. if you've ever used solar, ours is a little bit different, but there's Jack back there. Hi, Jack. He's our solar guy. Solar is amazing. It's we embed it again with Cassandra, but what it does is it creates a really amazing indexing engine for your data that's inside Cassandra. So what I would do is take that video table, the video column family, and index that with Solar. The descriptions, I would get keywords out of the descriptions and out of my tags, and then I can have search. I can add search capability to my video website. So if I'm looking for certain keywords like cats, fire, hilarious, I'm going to do those searches. Solar is going to help me find those videos on there. And again, because it's embedded with Cassandra, the data doesn't have to be moved. It's all indexing data. It's indexing data right on Cassandra. So as new videos are added, Solar is indexing that data. That is really cool. I didn't have to move anything. And it's all operating within the same cluster as well. So, the other thing we offer is Op Center, which is, I had to put in a shameless plug for our poor little Op Center. That helps you run your cluster. So whenever you do have that problem with scaling and you need to get more, this will help you. Op Center is available for free as well. So there's a community edition if you just want to use it in your environment. It's fine. The enterprise version adds several things like backup and soon deployment. So there's two different flavors of that. So you can download the DataStax Enterprise with Hadoop and Solar for free off our website. Go for it, have fun. We only ask you pay for it whenever you use it in production. And same with our community edition, which is Cassandra. We try to follow the Cassandra Apache and we package it with dev files and RPMs. Again, since we are the Cassandra company, we've created a community version and an enterprise version for enterprise customers. So it's a little more hardened, a lot more QA on it, but the community version is a little faster moving, so it's going to be right off to the top of the trunk on the Apache website. So you can have either of those. That is it. How am I doing for time? Wow. All right, questions. All right, let's see it. Questions? Come on now. Who's going to break the ice? Right. Go ahead.
So, like, suppose if you have 3 M1X larges, and like, at what point do you say you should be scaling up your cluster? Like, what are the indicators of?
That's a good question. There's a few factors. Usually, it's one of two things.
The reason you said M1s, is it like Cassandra would require more memory? Would that help rather than C1X larges?
Memory is usually.
Can you repeat the question?
Yeah. So the question is, I think I heard it, is like when to go from like an M1 extra large to something larger, like, and when to do that.
Yeah. When do you know that? Like, what's the time and what are the indicators for moving up from a 3-node cluster?
Like when do you, like, how do you know to move from 3 nodes or get a bigger box or any of that? The terrible answer is it depends. No, there's a few things to look at. One thing is, of course, the volume of data. You don't want to overload a certain node. You don't want to put terabytes of data on a particular node, on one node, and try to load them up with just a lot of data. Especially in Amazon, you wouldn't want to do that. The other thing you want to look at is your writes per second. I can give you some calculations. There's some, you can do some rough calculations on how many writes per second you can get out of your nodes. And if you start seeing that get closer. But generally what you're going to start seeing is read latency or write latency start to creep up. There are little indicators, and that Op Center that I showed you will show you some of those indicators. So if let's say you have a high load event, like all of a sudden everybody just started rushing on your website, and you saw the read latency go up. Okay, you can notice that, you can alert on that, and you say, okay, we're starting to see some read latency here, which means we're probably getting beyond our capacity. Then let's go ahead and add a couple more nodes. And so there's a lot of different factors as part of the operations, but it's just simple little things that you probably already do already with you. The good news is, like, whenever you watch those kind of stats, say like MySQL, and you're like, oh no, my query latency is through the roof. What am I going to do? I'm going to start dropping indexes and stop and drop. I'm going to drop all my relational integrity. You just start dumping things out of your your data model to try to make it work, or denormalize it. With Cassandra, it's like, oh man, we're using way too much. Let's just add more. And then you're moving into the next tier. That's fine. Or, yes, sir?
What is the configuration you would recommend for commodity server? You said.
So what's the recommendation for a commodity server? I'm glad you asked that, because this is now being recorded. What I really like is super micros. And I'm thinking of that class of machine. Now, let me put some caveats in here. If you have a very high tolerance for, if you have a lot of machines, you can really get your tolerance is going to be in the numbers. So you can get some very, very pathetic machines and a lot of them, because if one dies, you just let it rot. It's okay. But if you only have a few machines, you want to have a Supermicro is a great machine. I like talking about Supermicro because it's not the highest end box, and you can get them at a pretty affordable price. If you get a Supermicro with reasonable, most of them have pretty similar CPU configuration now. Whatever's available now is probably fine. Dual cores, dual socket machines are great. And having enough disks to hold your data, maybe 4 disks, 6 disks, and put it in a RAID configuration. For a spinning disk, we don't want to see a whole lot more than 500 gigs per box, so you want to have a smaller box. Now, if you're using SSDs, you can go crazy. 2 terabytes. SSDs and Cassandra work really well together. I was talking to one of the other architects, and our dream box was a Supermicro with the Samsung SSDs in it. You could probably put together something like that for a couple grand, and it's the dream box for us.
How about memory?
Memory is important for caching. So if you're going to do a lot of caching, I like 32 gigs is a good number now, or more, based on how much caching you're going to do. But I'm seeing boxes now that are pretty normal that are above 100 gig, because memory is pretty cheap right now. I have a lot of customers in the 190 gig range, 192, 196 gigs of memory. And that just really makes those boxes fly because there's so much caching on them. And because Cassandra is very consistent with its caching, because it's in lockstep with what's being cached, it's a very efficient caching machine. So you don't need to put memcache in front of it. Memcache in front of Cassandra means now you have to deal with cache invalidation. Whenever you use the cache efficiently inside Cassandra, yes, you're still getting cache, it's still coming out of memory, but you don't have to deal with the cache consistency problems. So that's why I like adding a lot of memory to the boxes if you can afford it. You could probably get away with 16 gigs, but I like to have a lot of memory in the box. Acme Micro in Fremont sells great machines. And they really are a company. Look them up. They have a great website. It hasn't been updated since 1990. I used to buy servers for them by the pallet because you could just get them cheap, and that's the way I like to buy my servers.
So whenever you are writing from, like say the cache to one replica, how do you actually, so you write it in 3 locations from the main cache and stuff? How does it work? Like,
it's because of the way that memory works with Cassandra. So when an insert comes in, it writes it to a mem table first. It doesn't write it to the disk. It writes it to a mem table. And that mem table is replicated, and then it replicates that data to other mem tables. So those are all sitting in mem tables initially. And so what you're going to get out of that is everything's in memory initially. And it'll flush out the disk eventually. There's a funny situation I had where I had a customer, a pretty large customer, that just fired up a new cluster, a big one. And they hadn't seen any SS tables being written yet. And it's because they had so much memory that their mem, and it was so distributed that it was still sitting in mem tables. And eventually it will flush out. It's based on size of the mem table and how many operations. And they just didn't have any, they didn't have enough volume of data yet to write out any SS tables. But that's why I say there's a strong consistency with cache. Okay.
So I've been hearing about data stacks in the Walmart lab space for a while. So what use cases or business applications are you helping us out?
Let's see. What can I talk about?
Yeah, this is a mixed event, so I think it's,
Yeah,
yeah. So
Well-
general stuff, I guess.
general stuff. Making really fast applications.
So what I was hinting at is, typically we are an online business company, right? We are all about orders and very close control about our inventory,
That's a generalized
transactions.
use case that I could talk about, because what, you brought up a very good point. Online. Online is all about volume and crazy weird loads at different times, Black Friday, you have these moments that you need to have to load. And also reliability. There are a lot of databases out there that talk about high availability. Cassandra's about continuous availability. That means you can do any maintenance, you can have nodes drop out. It's still going to be online. High availability is great if you're okay with downtime. And so when you're talking about online, you want it online all the time, 24/7. And you don't want to have windows like, back in the day, I used to have maintenance windows on our website because we had to do something with our relational database or something. And you shouldn't have to do that anymore. You really shouldn't have to do that anymore. So those kind of use cases are perfect. You can fit your data model in there. Things fit well in Cassandra. And because all those other topics are somewhat cheap, it replicates naturally just this way it's built. And it scales very easily. It's very linear. Those are the easy topics. Now, get your data model in there and take off. That's a good use case for online websites. We can talk about Netflix, who's all over this. That's what they're doing. They're all their online businesses running on Cassandra. Every bit of it. There's no relational in their mix. We could talk about something else, right? Yes.
So how does Cassandra assures full data consistency?
Good question.
What about the high write applications where you're writing too much, and how do you avoid the phantom reads or dirty reads?
So the question was about data consistency. How do we guarantee data consistency? So Cassandra is tunable consistency. So if you don't care, we can support that. If you really care, we can support that too. There's two things that really make that consistency work. And that is, the replication factor is one thing, how often, how replicated that data is in your cluster. So let's go for the highest one. I want to make sure that everything I read and write is exactly the truth. So what I would do is I would set up, let's say we have a small cluster of 3. I'll have a replication factor of 3. And every time I do a write, I do a consistency level of all, meaning that all replicas have to say, I have it. So when you do that, you're pretty much locking up that data. That data is now there, and it's guaranteed to be there. When I do a read of all as well. Guarantees that that data is exactly what the entire cluster thinks is there. So that's the highest level of consistency that you can have. So this would be great for things like your shopping cart or some sort of financial transaction. You really want to make sure it's, and you can tune that consistency per query. This isn't something you have to set up on your database and then everything follows along with that. You can tune that per query. So let's say you go the opposite direction. Here's some video streaming data. Yeah, if it shows up, it's fine. I'm really not that worried about it. For that, I may have a replication factor of 1 or 2, and then I go with the minimum consistency level, which is 1. So one replica says, I got it, I'll handle it from here, and then it may replicate it eventually. That's the eventual consistency that we hear about in Cassandra. Yes, you can have that, but if you don't need that, if you need more, you can do it.
So isn't in that case it becomes just like a relational database and then with a cache on the top? If you are 100% guaranteeing everything, because then you're not using the real features of NoSQL kind of write.
I know what you're saying. So does that kind of invalidate the NoSQL? What we're trying to do is give you choices to work within different use cases. So yes, that is very much like what, like I say, MySQL would do. But let's also, what you're not having in this case is a single point of failure. So that's gone still. So if you have a node that goes out, your data isn't gone. Now, if you're still saying that I need a consistency level of all, it won't write it because that node's offline. You can tune that back if you want to do like a quorum or a one. But yeah, but that's really up to the use case. I've seen so many different mixed loads on one cluster, just because, oh, well, this one's got to be there. You know, like say for instance, a credit card transaction. One thing on our website that has to be absolutely consistent. Okay, tune that up. The rest of it, you know, I changed my username. Okay, we'll turn that to a quorum. Oh, but I put a comment on a video. Now tune that to a one. So you know, you get a mixed use case. Yes.
How much is the performance difference in these two cases? If you have least consistency and most consistency, how much is the performance impacted by that?
It does impact the performance. Replication factor is more of a direct cause for the performance. So you could do so many writes per second per node divided by the replication factor. So that's a pretty big number sometimes. So if you had 3 nodes and you had a replication factor of 3, then those writes per second per node is now divided by 3. So that, but you know, you're still in the thousands. But it does impact it, and that's something you do consider whenever you're doing your deployment. How's my replication factor going to affect my particular load? Maybe in this case, like my video stream, I'm only going to have a replication factor of 1. That's going to really make my writes super fast. I'm going to get the fastest writes. That doesn't mean that the data is going to disappear. That just means that it's going to be, it may take a while for it to show up on another node. So tuning that is all about those performance characteristics. How do you want your data to be? How fast do you need your data to be? Now let's say that you want to have the most strong consistency, and there is a performance penalty on that. Well, the way to solve that is just to add a few more nodes. So you can kind of backfill your nodes, and you can handle it, because there's a great paper on this that was done at the University of Toronto about how different databases scale. We also have a benchmark at Netflix. Cassandra scales like that. It's a linear relationship. If you add more nodes, you get more writes per second. And it just keeps going and going and going and going. So that's really nice for operations people, because then you can plan ahead. It's not a curve, it's not a log curve or anything like that, it's a straight line. So if you need 10% more capacity, you add 10% more servers.
The updates are actually inserts, right?
Mm-hmm.
How the transaction data are handled? Like, for example, account balance. Its update happens.
Yeah, so like transactions.
Right.
All right, so of course, Cassandra being distributed does not handle transactions across multiple column families. We do have row level isolation though. And this is one of the more important features, I think, of 1.0 that came out, which was